Good morning. We had reached a point in our discussion of chemistry where we had learned about the atom, and we learned about the main ways that atoms achieve stability through interactions with other atoms in what we would refer to as chemical bonds. And what drives chemical bonding is this thing we call the rule of eights. And what it's making reference to is a atom gains stability, desires to have filled by having, or two desires to have a filled outer electron shell. And so we had talked about two different ways that they could do that, either by giving away an electron to someone else, ionic bonding, or sharing pairs of electrons. And then we had said in some cases when they share pairs of electrons, the electrons spend more time at one or the other ends of the molecule, and this creates a situation where you have a partial charge on the molecule. And so water, I've written up here, water is a polar covalent molecule, meaning one end of the molecule is partially negative while the other is partially positive. When you have that situation, the attraction between multiple molecules, this attraction of one molecule for another, the partially positive end attracted to the partially negative end of another molecule, this is what we call hydrogen bonding. And it explains some of why water behaves the way it does. And so water beads up, we had said. Water sticks to itself. The term for that is cohesion. You may have, at some point in your life, gone to the doctor and they prick your finger, get that little spot of blood, and then they stick a little glass tube down into that little puddle of blood, and the blood, like magic, moves up the capillary tube. And maybe you never even gave it a second thought, but if you did think about it, you'd be, why? Why does the blood move against gravity up into that tube? And the reason for that is because the inside of that tube is charged. Blood is mostly water. The water in the blood is attracted to the charges on the inside of that capillary tube, and that's what moves it up. The process of water being attracted to other surfaces is called adhesion. Now, if we think about cohesive water and we think about boiling, so when you add heat to a substance, the molecules start to a liquid. When you add heat to a liquid, the molecules start vibrating and moving away from each other. And if you have a non-polar covalent substance like gasoline, you add heat to it, they just vibrate apart. And it happens very quickly, and so we would say the boiling point of gasoline is low when you compare it to water. Because why? Because of the polar nature of the water, it's always breaking loose from one molecule and grabbing onto another one. And that means it takes a lot of heat to boil water. And so the term for that is water has a high specific heat, a high boiling point, and it can absorb and hold a lot of heat in those vibrating molecules. Now, what else is weird about water? So when we talk about states of matter, we have gas, we have liquid, we have solid. In most substances, the molecules in a gas are the farthest apart. The liquid, kind of in between, and the solid, they're close together. In water, that's not the case. It's really an unusual molecule. Water is most dense, meaning the molecules are closest together when it's cold, but not frozen. 4 degrees centigrade, it's about close to 40 degrees Fahrenheit. Water is most dense at that point. And as a result of that, since ice, solid water, is less dense than cold water, ice floats. So you see there's some really weird qualities to water. What else? Do we have anything else I want to say about water? Let's see my notes here. Oh, yes. When we talk about human anatomy and physiology, we can talk about we're mostly water, 70% water. So the solute, the solvent rather, that the chemicals are inside of me is water. And so solute is the dissolved stuff in the solvent in the water. So water is the solvent for life. Some substances love water. They're hydrophilic, and those would be things that have charges on them. So stuff that will dissolve in water is generally polar. Non-polar stuff does not dissolve in water. So you think about that gasoline or oil, you put it on, pour it in water, and it's going to float. Why is it floating? It's trying to get away from those charges. That would be hydrophobic. Okay. All right. Okay, that's enough for this video. We'll come back and we're going to start talking about acids and bases, but we're going to continue. We'll make a little segue with water again, because water is the solvent for life.